Hello everyone, in this video we will be starting with a new series of machine learning. In this series we'll be focusing mostly on implementation of machine learning concepts rather than directly going into theory and then coming to implementations, because I think it is more beneficial if you learn through practicing than whenever there is a need for theory I'll be explaining it to you on the slides, but right now we'll start with the implementation. So today we are going to deal with a very simple basic pre-processing stuff using the very famous Titanic dataset. Okay, so let me directly get into the topic. So first we will import the dataset. So I'm going to show you a way in which you don't have to download anything. Okay, I'll give you the way. So we'll say pandas as pd and also import numpy as np. Okay, so the way we are going to do it, we are just going to use the link. I'll share the link in the description below, so you can go over there and use it. So I have this link over here. It's there on GitHub. You can directly paste your link over here and directly get the data set. So we'll be getting the data set in df. So what we can do over here is try to see the head, that is the top 5. So what is df.head? It is going to show you the top 5 tuples. So now the first thing that you should do whenever you are approaching a machine learning problem is to see the data set and try to figure out what are the classes are there. So I have written over here some points that we will use. Okay, so first is passenger ID. Okay, now what is the Titanic? Obviously some of you might have seen the Titanic movie. Basically there were some people on that unfortunate day. They were on that ship which sank and a lot of people died. Some of them thankfully they were saved, but a lot of people died. So that was the overall story. So you have the data set. So first is the passenger ID. Now what is the passenger ID? Obviously there are they might have given some names to the, or rather the, as they say, ID to every person. So the important thing here is there is survived column. So basically whether this person survived or could not survive, what class they were in, okay, what was the name of the person, what was the gender, what was the age, whether they had siblings or not. This is SIB, SP. So you can see over here number of siblings or spouses, okay, on the Titanic. Then parch was number of parents or children. So over here you can go and see number of whatever the parch. Then ticket number, I don't think that's very important. Fare, what price they had paid for the ticket, whether they were in a cabin or which cabin. And last, what was their embark station, basically where they had boarded. So for port of embarkation, so there were 3 ports: Cherbourg, Queenstown and Southampton. So obviously once you look at this data set, you need to understand what are important and what are not important. So obviously we can say that the name of a person is not important because you already have the gender. What name? There's nothing in a name, as Shakespeare said. So we already have the gender, so we can drop this. Do you need the age? Yes, you will need. Do you need number of siblings? Some people might say that's important, some people will say no. Parents, I think that will be important. Obviously ticket number is not important, so we can drop that. So basically what we are trying to see is look at each and every column and figure out whether that is important or not. Ticket, obviously no. Fare, maybe. Cabin, I don't think so. So what we are the first pre-processing step that we are going to do is we are trying to figure out what are the nan values. What if in some of the column there are values that values are generally, for example, most of the people do not know what cabin they were those guys were in. So for example, in order to figure out what so we are going to say finding out the missing values. So as you can see over here, nan means not a number, which means this one is missing. So the cabin number of this Mr. Owen Harris, we don't know. Similarly here, nan, so we don't know the cabin number of Miss Lina, and same thing for this person. So we are going to say finding the missing values. So the first pre-processing step that we do in machine learning is to find out whether the missing values are there, and if there are missing values, how to deal with it. So the way we are going to do it is we are going to use a function df.isNull. So we are going to print this. So let me first take only the, okay, let me have this. So you can see most of these are false, but here it is true. We have seen whenever there is a nan, which means not a number, you are getting a true over here, which means this particular value is missing, and this particular value is also missing, this particular value is also missing, this particular value over here of 8 86th person is missing, which means cabin numbers are missing. Over here you can see this age of this person is also missing, true. So wherever there is true, it means yes, it is missing, that is null. So how to find out how many of them are null? So you can do dot sum. So this will basically give you column wise how many missing values are there. So for passenger ID we don't have any missing value. For survived we have all the people who the data of the people whether they survived or not. For the classes also you can see over here age 177 people, we don't know what their age was. Cabin almost like a lot of people, 687, almost 700 people we don't know, and embark two of them we don't know. So let's try to find out the percentage. So we will say df.shape. So how many df.shape is going to basically tell you how many columns, how many rows are there. So we will take df.0, and it turns out that we have 891 rows. So what percentage of values are missing? So we are going to take this, okay, copy it over here and then paste it over here. Sorry, then paste it over here and divide. Now what you're going to get is, you can see over here 19.8, almost 20% of people don't we don't have their age record. 77% of people we don't have the cabin. Now you might think, if we don't have 77% of the record, is there any use of keeping this column? Well, I am saying that there is no use of keeping the column. So the first step of pre-processing after finding the null values is to figure out which are the values or the columns we are going to drop. And there are other ways also. So sometimes you drop the column, sometimes you add certain things which I'll show you in the next step. So first let me go and drop. So the way you drop is you say df.drop, and then if you're just using one column, because you are only dropping cabin, cabin over here, we're only dropping cabin over here, what you can do is go over here and just say cabin. If we had to drop multiple, we would have used a list. We will use a list, which I'll show you in some time. Then you have axis equal to 1. Now what is axis? So axis equal to 0 means rows. So let's say you want to delete this particular row of, let's say, Miss Lina. You want to delete this particular row, you would say axis equal to 0, because you have to delete row wise. For that you will say axis equal to 0. But if you say axis equal to 1, you are deleting column wise, so you are deleting the entire cabin, right? So we are saying axis equal to 1. Now this is still not done, but I want to show you something. If you print it, let's say shift and enter. Okay, so the first problem that we are coming here is the C is capital and we are using small c, so that is a problem. Okay, so here you have to use capital C, and once you are done, you can see over here the cabin is missing. So we have fare and directly we have embarked over here. Okay, if you go here, you see there is fare, but then after that he had cabin, so we have dropped the cabin, right? Well, actually it turns out we have only dropped it in this line, which means if we again do df.head, what you are going to see is we have the cabin intact, which means it was never dropped, only the copy was dropped. So in order to make sure that the column actually is dropped and you don't get it back, you have to write something as in place equal to true. A lot of people, commit mistakes over here, so that's why it's very, very important. Now if you do df.head, that should be totally gone. So you can see after fare there is directly embarked, so our column is gone. So we have totally dealt with one of the columns, but what can we do for the other tables, other columns we are going to see. So if you go copy paste over here, you are going to see that totally that cabin was removed, but age we still don't have 20% of the values. So whenever you have these kind of things, what you do is you have to see the age factor first. You have to see age. So age over here is a numeric value. Can't we just take the mean and fill those values? Which means wherever there is a null or a nan, you fill it with the average of the values that is already present. So how to find the average? We are going to say df.age. Okay, so if you print this, you will get all the age values over here and find the mean. So you are basically going to get the mean of all the values that are present. Nan values will be avoided. Okay, so you have the mean. Now what you want to do, you want to just call it mean. Now what you want to do, you want to replace the values wherever there is nan. So you're going to say the function that we use is df.age, so that is the column, fill na. So this is going to fill the na or nan values. With what it is going to fill? It is going to fill with the mean value, and in place equal to true. Why? Otherwise it will not make change to our deep copy or the real copy. So let's put it over here. Now we are going to print this. Now we're going to take this and going to print it again, and hopefully that age should be the missing values of age is now 0.00%, which means all our age values have been put over there. Lastly, we have some values over here, embarked, which is again missing. So here you take a totally different thing. Why? If you go to the embarked section, you're going to see there are, we don't have, here we took the mean because these were integer values. Here we don't have integer values. Here we have class values. So what I am going to do over here is I'm trying to figure out what is the distribution of the class. So I'm going to say df.embarked, and then you can use the function value counts. So this is going to basically give you, I had run it before, this is going to basically give you what values are there. So there is S, C and Q. So basically only three types of values there are, and S has 644 occurrences, C has 168 occurrences, and Q has 77 occurrences. Now what you can do, we saw that this is only what, 0.002%, only two of them did not have an embark. So why don't we replace it with the mode, right? It shouldn't change a lot of things. So what we are going to do is we are going to use again the same thing, df.embarked, embarked, and then what you are going to say, fill na. Why? Because it is going to fill the nan values. With what we are going to fill the nan values? We are going to fill with capital S, right? And then again in place equal to true, and we are going to hit shift and enter. Now let's look at the head, and hopefully our value should be intact. And the way we are going to find out whether we are able to, whether we have actually removed all the nans from here, and we have, we are done with the first step of pre-processing. Yes, you can see that all of these values are now 0, which means we don't have any more nan values in our, or null values in our data set. Now let me go and print the head one more time to see what else we can do. So now we have already filled the nan values. Now let's remove those columns which we don't need. Do we need the passenger ID? No. Do we need the name? No. Do we need any other thing? We don't need the ticket. So why don't we go and delete those? So we are going to say we have already used drop, but now we are going to drop multiple columns, and that I said you need to use a list. So I'm going to drop name. I'm also going to drop passenger ID, and also I'm going to drop ticket. Okay, again the same things, in place equal to true and axis equal to 1. Let me go and run this. So now if you see, we will get a more simplified data frame. So as you can see, those extra columns have been deleted. You have survived, which is basically whether the person survived or not. We have a class which we will need later. We have the gender, we have the age, we have the number of siblings and the number of parents and all the stuff. We have the fare and we have the embarked. Now we will go to the second step of pre-processing, which is converting text labels or categorical labels into one hot encoding. Now why do we do that? For text labels it is simple. The computer does not understand male, female or type of English words. What we need to feed to the computer are numeric values, and for that we will be using some techniques to convert this into numeric values. We call that one hot encoding. We will see that in a second. Secondly, this P class, it can only take values. So if you want to see the unique one, you have to go and P class dot value counts. So you hit shift and enter. So as you can see, these are categorical values. Only three of them are there, 1, 2 and 3. So obviously we know that being in a P class 3 is nothing more, is not numerically different than being in P class 1 or 2. Means they are just representation. They are not defining or declaring any kind, they are not representing any kind of a numeric upper or greater kind of value. These, this can be THREE or ONE and TWO for 2, which means that these are just categorical values which are looking like integers. These are not actually really, I mean, this can be your class can be, first, second or third instead of 1, 2, 3. it can be a text, which means just like this column, we also need to change this column as well to one hot encoding or some different representation. Same for embarked. This is again S, C and other. We don't want these alphabets because the computer doesn't understand. So how we are going to do it? Well, there is one way in pandas that we do it. We say pd.getDummies, and then what we are going to do is we are going to pass the first one. Okay, so I'm going to pass df.sex. So let's see what happens. So you can see over here that in gender, obviously there can be male or female, right? So here it has now two columns, female and male. Now what happens is, so our gender column looked something like this. Okay, so we had over here, so I'm using a new to say pen, so I'm a little bit it's new to me, that's why it's taking a little bit of time and maybe the writing might not be that good. So let's say there is female, then you have male, then again you have a female, and then again you have a, let's say, a female, and let's say again you have a male. Okay, just forgive my handwriting, okay, for because it's a new one for me. So how you're going to represent is, you're going to have two columns. You're going to have a column for female over here, and you're going to have a column for male over here. Okay, now the first one, you can see it's a female. So under female, in one hot encoding, what happens is you write here a 1 and here you write a 0. Okay, same thing over here. Now it's a male, so inside the female it will become 0 and here it will become a 1. Now again female, which means 1 and again 0. Then now again female, so 1 and here 0. Now male, so 0 and here 1. So I hope you understand how this is converted. Okay, so I hope you understood how this is converted over here. Now what we are trying to do is, we have to take this and append it to our data frame, and the way we are going to do it is by using something as df.join. I'm going to explain you how it works. So the join operation is very simple. Let's say you have a data frame over here. Okay, so let's say this is your big data frame. Okay, so what happens is, now let's say you have another column, you have, let's say, only two of them over here. Okay, over here. So what happens is, now these two will be joined, and what will be happening is the length will remain same. So let's say this is 100 values over here, then this will also be 100. Okay, this will also be 100, and now this again will remain as 100 itself. You will add only the columns. So let's say there were 10 columns over here. Okay, so from here to here there were 10, and let's say here there were only 2. Okay, from here to here, so now it will become 10 plus 2, which is 12. Okay, so these will become 12. So I hope I was able to explain how this is. So basically you add this one to this position. Okay, so in order to join it, you say df equal to df.join, and then you pass this whatever we have created. So let me give it a name, let's say gender. Okay, so this entire data frame will now be called gender, and we are going to have a gender join. Now after that, we are going to again see what the head looks like, and hopefully we will see. So obviously you can see over here the male and female has been added. So you can see over here male and female has been added. So we can obviously delete this also, but let me first go and do the same thing for P class. Now I am going to show you a little bit of a different thing for P class. So as you saw, there were male and female classes, and now male and female, and now they have become your column name. Now obviously in P class there is 1 2 3, and we don't want our columns to look like 1 2 3. So what we can do, we can use the same thing over here, and instead of gender I am going to say PC, P class. Instead of here I am going to say capital P class. Okay, now we can use something as suffix. Okay, sorry, it has to be prefix, not suffix. So if you print prefix PC, you can see over here, if you print PC, you can see whatever we gave as prefix, it is already there, followed by the class name. So _1, _2 and _3. So these were the individual class names. And now to do the same thing, we'll have to join it. So we are going to just copy from here, and then over here you can go and paste it, and instead of gender we are going to have PC. Now let's see, and then we are going to have df.head, to see where we have actually reached. So you can see P1, P2 of these are added. Now let me do the same thing for so what is left, embarked, right? So again what we can do over here is go here and let's copy, paste, and here say em embarked. Instead of p class we are going to say embarked, and instead of we are going to say just em. Okay, so we are going to here and then we are going to print it to, let's see what is the output. Again you can see emc, emq, and ems, and all our values, as I said, have become one hot encoded. Lastly we are going to join this. So again copy from here and then paste it over here, and instead of PC we are going to say em, and then hit shift and enter. Now finally we will have our data frame that is going to contain all the values in the zero hot encoded format. You can see from male, female, p class, np, emc, emq, and ems. Now obviously since these are already now in one hot encoding, what we can do is delete this gender, p class, and embarked. So again if you remember we are going to say df.drop, then over here you can go and say x, you can go and say over here p class, and lastly you can also have embarked, and finally again access equal to 1, in place equal to true. Okay, now finally our prepared data frame looks something like this, and we have done almost everything except normalizations. So that is our second step. So the first step was dealing with missing values. Okay, second step was changing text or categories, categories to one hot encoding, and lastly the third step is to normalize, or we will say, or standardize. Okay, so for that what we are going to do is we are going to use something as over here min max scaler. So what is min max scaler? Okay, so what is min max scaler? So min max scaler, what it does is basically it tries, let's say it has some values, let's say 10, 20, 30, 40, and here is 50. Okay, it has these 5 values. So what it will go is it will first find the min. So min is going to be, it's going to be 10. Okay, then max is going to be your 50. So the formula for min max scaler is, it says x, whatever is the value, minus min divided by max minus min. Okay, so what it does is it tries to get whatever the value is between the range 0 to 1. Okay, so all your values will be from the range 0 to 1. So let's say for the first value it is 10 minus min is 10 divided by, what is your max is 50, what is your min, divided by 10. So this will going to give you 0 because 10 minus 10. So let's say for 30 you have 30 minus 10, and over here you will have again 50 minus 10. So this is going to give you 20 by 40, and this is going to give you 1 by 2. Okay, so that's 0.5, and the maximum value is 50 minus 10 divided by 50 minus 10. This is going to give you 1. So your entire range 10 to 50 has been reduced to 0 to 1. Okay, so this is what the min max scaler does. Now why do we do it? To make the training more stable. Okay, so the way you use it is you go over here and you can use from sklearn.preprocessing. I'm not going to type it, I'm just going to copy paste from here. So I take it over here and then paste it, right? So once you are done with that, you're going to use a scaler. So scaler equal to min max scaler. I'm just copy pasting because I have already explained what it does and how it does it. You can go over here and you can say scaler s, I'm just going to say sc, so min max scaler. Okay, so now the way you do it is you say sc dot fit transform, and you're going to transform what? So you're going to first transform, you do it column by column, okay? So first you're going to transform the age, right? So you're going to say df dot age, and let's call this sc age, okay? So this is for scaling the age. So sc dot age fit dot transform, fit transform. So sometimes you do have this problem. Basically, it will say you to reshape it into a certain dimension. So what you do is you go over here and you take the values. So values is basically going to convert it into numpy, and then what you say, you reshape it to -1 comma 1, and then you hit shift and enter. So you can see all these values, all the values are between 0 and 1. None of the values are between are lesser than 0 or greater than 1, okay? All these values. Now what we can do is we can directly put it in a data frame. We can say df dot new age. So this is the new column for age, and we are going to say we are going to hit shift and enter. So it will create a new column for us with the new age. As you can see, new age, and all the age has been normalized. Then what we are going to do, we are going to create another min max scalar over here, and this one we are going to create it for fair, okay? So we are going to create it for fair. We are again going to copy from here and then paste it over here, and instead of age we are going to say fair, and here you are going to say new fair, and here instead of age we are going to have fair, okay? Same thing. And let's finally go and see what we have got over here. So you see the new age has been normalized and new fair has also been normalized. Lastly we can delete fair and age. So again the same thing, we will say df dot drop. We are going to say over here fair, and also we are going to say age, right? And then x is equal to 1, in place equal to true, and then finally, so this is our real data frame that we will be using for training and testing. So this is our new data frame. So this is the survived column that we have to predict. So this is our target, and all this is our features. Okay, so in our next video we will be seeing how we can break this entire data frame into train and test, and how we can use it to train a simple logistic regression model. So I think this is enough for today. If you really like the video, to please go and hit like and subscribe.